Fabulous. We are live and we will be waiting for people to join us. So, hi,
Okay.
Dominic.
Good. Hello.
Let's give it a couple minutes and see when people join us,
Yeah.
just
You
so
can
we
give
don't.
me the green light when should I start because I don't see anything on my screen besides.
Actually, you know what? People were quite early this time. We already have a few people who have tuned in. So I will just exit the screen and the scene, and I will leave it to you, Dominic.
Okay.
Fabulous. Enjoy.
Thank you. We'll wait 2 more minutes if anyone else joins up.
You know what? I think you can start, Dominic.
Okay. Sure. Okay. Well, I welcome all to this webinar. I'll try to keep it short and sweet. And this topic will be around mastering AWS strategy savings in the future. But all that we will be speaking here isn't only applicable to AWS because all clouds are pretty much similar. Mostly the terminology changes. But basically, we'll talk about practical scaling strategies, whether you're building from scratch or refining an already existing system on a new project or at your client by exploring best practices for autoscaling, load balancing, and modular architecture design. All will be illustrated with real-life examples. So we will talk about companies that we all know, how they are tackling their problems, and how they are solving the cost, mostly the cost, and the strategy that they use to have the uptime at all times. And some of those companies, as I said, you already know, there's Zalando, Monzo, Slack, Snoop. And as we speak about their examples, we'll transition into actionable cost optimization techniques, basically showcasing what they're doing. And finally, we cover the latest innovations in the serverless computing and AI-driven automation, and discussing how these emerging trends are applied in practice. So to basically drive efficiency and agility. So let's get started. First, of course, we'll talk about strategy itself. And most obvious, and the most important part for keeping costs low and your system up 24/7 is, of course, the strategy. But it's often skipped and not enough emphasized. I don't know what is the main reason behind, perhaps just to get things started, but the technical depth can get costly, mostly costly in the late game, I would say. So think of it like building a solid foundation for a house. If you plan it right from the start, you avoid a lot of headaches later. So by designing your system to scale and bounce from hiccups, you can use resources smarter and cut down on unnecessary costs. And as I said, believe me, those can stack up pretty fast. There are numerous examples on internet where people turn on some services and the bill can get 100K and more, just easy enough. So basically, this approach with strategizing your approach to the cloud, you dodge unexpected outages and you keep your services up and running even when the demand spikes. And we're going to break it down with real life examples and best practices, showing how smart strategy can actually save you money and keep things running smoothly. So for our first example, we have Pinterest. So a large enterprise, one well-known and global visual discovery platform. That will be the description. So it's home to more than 500 million users worldwide. So, and it all started in cloud back in 2010. And basically, they use AWS to process huge amounts of data and serve up personalized recommendation to its users. I'm pretty sure you all experienced that. You go on Pinterest, scroll a few topics, and well, you know it. More of those are popping up and give similar recommendations as they're learning through their algorithms. But basically, they run their core services on Amazon AC2 with autoscaling, utilizing even the newer Graviton-based instances. Those are new, but not so new like yesterday. I think those are like 4 years old. But in the IT world, basically, they are new. And yeah, they're used basically to even more save money. But we'll talk about those even more later. So all the images and all the data they use are stored on Amazon S3, while they crunch numbers using managed services like EMR, DynamoDB, and real-time tools like Kinesis and Elasticsearch. And for that cool search feature, the visual where you can input an image, they actually use Pinterest Lens to power it up with machine learning on GPU instances using Amazon SageMaker, so another AWS service. And to handle hypergrowth, because of those viral traffic surges, there's still what would I say? It doesn't matter. But basically, they use horizontal scaling. It's basically splitting data into shards across different user segments. That way, they can unburden one EC2 and divide that traffic onto multiple DAS, thus, yeah, unburdening a single unit, a single server. And they're currently locked up in a contract with AWS. I think 2024 was the initial year, and they have 5 years to spend $3 billion, which is a pretty strong commitment. They migrated key workloads to more cost-efficient instance types to keep the spending in check. One of those is the Graviton we spoke about. And they embraced chaos engineering to ensure everything stays up and running. We'll talk about that one again also later, because it's how to say fairly new, but yeah, we'll address it later. And they also utilize CI/CD pipelines. They moved their iOS builds to AWS using EC2 make instances, and by that they cut their build failure by 80%. So yeah, that's a huge leap. Yeah. By continuously refining their setup, they manage the slash analytics cost about 30% and boost resource utilization by up to around 50%. Yeah, all through tight collaboration with AWS and Intel, which are pretty big steps, specifically for such a large company that they have such a huge spending billings. So 10%, 20%, those are probably millions. And another example is Monzo. Yeah. It's a UK digital bank that started in 2015, so fairly new. They quickly scaled to serve millions of mobile users. And as a regulated bank, Monzo needs to be online 24/7. And of course, strong security is emphasized. So they chose AWS from start to begin in the beginning to avoid the hassle about basically about their infrastructure, which is, I think, a pretty smart move in their case. But there are many cases, and we as well will be talking about when is really AWS or any cloud really a solution and when it's not. But to turn back on Monzo, they avoided the hassle of building data centers, which enabled to scale globally on demand. And the journey saw them grow from around 500 services to over 1,600, and everything is managed with Kubernetes on EC2. So they started with Mesos, with DSOS setup for in the beginning, but as they grow rapidly, they choose to switch back, not back, but to switch to Kubernetes, which was a terrific move in their case. So they build their architecture using independent microservices, so each component can scale as needed. Their core banking systems, like ledger and payments, they all run in Kubernetes clusters, while important data is stored in Amazon RDS, but they all back up their things in GCP, so they're not tightly connected to AWS, which is as well, I would say, a smart move not to put all eggs in one basket. And for security, they rely on AWS key management services, Cloud HSM, and Nitro Enclaves. Nitro Enclaves is fairly new from AWS, and I think it will be a norm in the security world, not only in cloud, but basically in the whole IT. They also use Service Mesh, link card, to keep the communication between the services, along with monitoring tools like CloudWatch and X-Ray, so to automatically adjust capacity when needed. And their multi-AZ strategy in London ensures seamless failover during outages. By switching from Marathon to Kubernetes, Monzo was able to cut infrastructure costs significantly, about 25% of what they were before. And currently, they're testing with AWS Carpenter. Most likely, they're already implemented with EC2 spot instances for even more savings. Basically, Carpenter is an open source autoscaler for Kubernetes nodes, which can improve the efficiency and cost effectiveness of running workloads on Kubernetes clusters. It's all tightly connected to the Kubernetes. As well, we got another, I would say, European giant. It's Zalando. And I think they're largest or one of the largest online fashion platforms. They handle around 120 million orders a year and over 25 million visits monthly. So the traffic can get pretty rough. And to deal with those massive traffic surges, especially during events like Black Friday, when orders can hit around 4,200 per minute, Zalando went basically all in on the cloud system, on cloud first strategy with AWS. So they migrated from monolithic system to more than 1,000 services, microservices, running as well on Kubernetes. Initially, they used EC2, even taking the advantage of the cost-saving spot instances. But in the long run, the switch up to microservices was, of course, a better move, specifically with that big traffic. And facing challenges like rapidly scaling for peak loads and to ensure high availability across multiple AWS AZs, and speeding up the future rollouts. And they had to inquire 200 independent teams, I guess, basically makes a team per 5 microservices. And they all, of course, built and deploy those microservices. They containerize their applications and future rollouts to spread them across regions to achieve the M+ redundancy. And basically, if anything happens to any AZ, all traffic is automatically switched to another AZ. You basically can't feel that anything happened because that one is always running in the background and waiting for their turn if something happens. And the result of all that is the record-breaking performance on Black Friday, where they process about 2 million orders in one day, while keeping, of course, the shopper satisfaction high and costs under control through those automation strategies. Another one we got Snoop, a little less known. It's a fairly new startup, like in 2022 they started. As well, it's a UK fintech startup. It's a personal finance app that connects users to their bank accounts via opening banking APIs. So they analyze your transaction and give users personalized money-saving insights and tips. And basically, in just 2 years, they scaled from zero to over 1 billion API transactions, while serving around 150 to 100,000 monthly active users. So Snoop opted for serverless, highly managed AWS architecture to keep things simple, cost-effective, and agile. So their platform is built entirely on AWS. They run Dockerized microservices on Amazon ECS with AWS Fargate, which means they don't have to worry about EC2 servers. And their Amazon API gateway handles their API endpoint, and ensuring everything stays secure and scale is needed. And to keep their microservices talking to each other smoothly, they use last time one of the example used linkers, they use AWS service at mesh and AWS Cloud Map, basically for service discovery. Although one note, I think app mesh is going to be discontinued in next year, so I'm not sure what will replace it, but I'm pretty sure that they're cooking up something. And for data, they rely on serverless databases like Amazon DynaB and store static content on S3, as well as the logs. And with support from AWS, Activate, and guidance from AWS Startup Solution Architects, they embrace the infrastructure as code approach from the start, allowing you to focus on rapid development and cost control. And this serverless model ensures that their costs grow linearly with usage and keep expenses in check as they scale. And the last one example is Slack. It says mid-sized company, but we all know that Slack is already a worldwide enterprise. But Google says that you are a mid-sized company until you have more than 1 billion revenue, and they are a little less shy than 1 billion, or 900 million or something. So we'll still classify it as mid-sized. And since we are all familiar with Slack, a little less known fact is they use AWS. So a workplace messaging platform that went from small startup to a major enterprise tool. They were founded in 2013 and they went public in 2019. They build a robust and scalable architecture that handles real-time messaging and file sharing for millions of users. Their core setup relies on EC2 for application servers behind Elastic Load Balancers, with important data stored in S3 and managed using databases like Amazon RDS or Aurora. They also use caching like Elastic Cache with Redis to speed up access to frequently used information, so that even when thousands of messages fly back and forth, everything stays fast and responsive. Their architecture is all about simplicity and ability to scale on the fly. That's the biggest advantage. For example, when an entire company logs in at 9 a.m., auto-scaling groups quickly add more EC2 instances to handle the load. They use multi-tenancy and distribute services globally with tools like CloudFront or Global Accelerator, depending on what you need at that moment, to keep latency low no matter where you are. By offloading file uploads directly to S3, Slack eases the pressure on its core service, so they make real-time interactions smoother. They also built in plenty of monitoring and automation using CloudWatch and to regular failure testing, ensuring that if something goes wrong, the system recovers fast. And of course, on the financial side, Slack leverages reserved instances and savings plans to keep AWS costs predictable, even as they scale rapidly. And to emphasize a little more on the Slack, I think doing this for every example would take a lot of time, but we can talk about it for this example. For the higher level flow, let's say users connect to Slack through the internet, and Amazon Route 53 directs their requests to Slack environments on AWS. And Elastic Load Balancer then distributes those requests across multiple Amazon EC2 instances that run Slack's web servers. And this ensures that no single server gets overwhelmed and that traffic is routed efficiently, improving both performance and reliability. And for real-time messaging, Slack uses WebSockets for it. So this means that once a connection is established, messages can flow in both directions without needing to repeatedly open new connections. And those web servers on EC2 maintains these WebSocket connections so that users get instant message updates. Content is stored on S3. As you can see, it's in the center of everything. All the files, all the images, and other user-uploaded content is stored in S3. And they don't have to worry about storage because S3 can expand infinitely. So storing those assets on S3 not only offloads the burden from the web servers, but also provides durability and scalability and basically easy retrieval of those files. So when a user shares a file, Slack can simply reference S3 and allow web servers to remain stateless and focus on real-time communication. The whole work process and background tasks. So basically, some of those EC2 are configured as worker nodes to handle asynchronous or background jobs, like, for example, indexing messages or sending notifications. So by separating web traffic from background text, Slack ensures that user-facing interactions aren't slowed down by any heavier processing. And for their relational data and search, they use RDS, most likely MySQL or Aurora, for storing relational data like user profiles, workspace information, and basically message metadata. They may also integrate a search service, perhaps Amazon OpenSearch or some of their custom, I don't know, to enable fast full-text searching across channels and messages. So this most likely gives them a structured and reliable data store plus advanced search capabilities. And for their scalability and resilience, this architecture is built to scale horizontally. If anybody perhaps doesn't know, the difference is horizontally, you can just pop up new servers all the time and go, wide. But if someone says that you have to expand vertically, basically you're just making one instance larger and larger. Perhaps their CPU is bigger, RAM or something. So this way, they're all the time able to scale horizontally, which is a lot easier on the system. And basically, this ensures, that they're unburdened, that their heavy lifting is always done on EC2 services without burdening each other. And the S3 ensures that content remains available even if individual servers go down. So those aren't affected by it. And everything is, as we can see, deployed in Amazon VPC, which isolates Slack's infrastructure and controls network access. This helps Slack to meet enterprise-grade security requirements and ensuring sensitive data remains protected. That was the last example. So, and basically we can ask ourselves, is the cloud always the perfect solution? And as the picture says, well, yes, but actually no. You have to have certain conditions or requirements, better to say, that you need perhaps cloud system over, metal bare server in your, I don't know, room or basically a whole server room. It's easier to start a startup definitely with cloud. Perhaps a good example would be someone from Europe starting something in USA, and instead of having hardware there, you just open up AWS, go to US region and pop up servers there, and you're good to go. And as well, if your company gets bigger and you expand on other regions, on other continents, you don't have to move your hardware around to have better connection with your users. Cloud enables that. I think in like 30 seconds you can enable that option. So it isn't the perfect solution for most stuff, I would say. It just depends on your requirements. But it is, I would say, a great tool for testing. Perhaps even the best module would be something in between cloud and local servers. Just because you can always have the same predictable traffic on your local servers. And for those expansions in traffic, for surges, then you can utilize the cloud, because it's a lot easier to have a few clicks and you have like, I don't know, 20 new instances, instead of, having a dedicated person who will then order servers, have them on storage, install them, prepare, and they are perhaps running at low capacity at all times. But you still have to pay for those, for the cooling, for the systems, engineers. So everything has its ups and downs. And well, as I talk about ups and downs, uh, as I said, mm, to emphasize another pro would be perhaps cost efficiency, because you're paying only for what you're using, which is perfect. And we got managed services, which means basically somebody already done the heavy lifting. You as a company, as a startup, or whatever your size is, you can focus on your product. You can develop new features and not invest time into keeping everything up and running. And as I already mentioned, global reach and high availability, perfect. Rapid provisioning and agility, of course, a great feature, and security and compliance. So although you have to still be up to date with all the security measures, the heavy lifting is done by the cloud provider. But there are, of course, the cons. So you got vendor lock-in. Basically, if you put everything into one cloud provider, doesn't matter which one. If you want to switch, well, the migration process can get a little bit hairy, and perhaps you are even contract binded, like Pinterest and many other. And if anything better opportunity arises, you have to wait it, and etc. Perhaps you're all familiar how contracts work. And of course, there's the cost unpredictability, like without proper monitoring and cost optimization. As I said, there are numerous examples where things go south because someone didn't turn off some service. And complexity in management, like managing multi-cloud or hybrid environments, requires specialized skill set, or most likely a company has a man just for that. And of course, the data privacy and compliance, to ensure compliance with different data protection laws. Now, UE has one, UE, EU, Europe has one, Canada has another, Africa has another policy. I know from my experience on one project, basically the thing was our traffic couldn't go through USA. So we had to figure out how to move from Canada to Europe to Africa without going through America, basically because of those data privacies. And the future and present of DevOps. I put the future / present because I would say that those two things overlap, I would say, for many years, not only in IT, but basically in all things. We talk about future as, for example, in electric cars, they're here for 15 years, but we still talk about them like those are the future, that will be the future. So similar things is with things here. So first we have the AI, which is like pretty getting popular in the last 4 years, but AI been here for like, I don't know, 40, 50 years. Machine learning was invented by Alan Turing in like the 50s, and the term was coined in 59. So the future is a long time already here. And I think that AI, of course, will still have will be highlighted in everything, but basically it will stay here for good. It will just become another tool. So imagine machine learning that can analyze your system's data in real time, predict where bottlenecks might occur, and even kick in automated fixes before you notice any downtime. So this smart approach not only helps to keep your systems running smoothly, but they also cut costs by ensuring only the needed resources are being enabled. And I think there are already numerous tools that are connecting to some of the AWS services. Like for Carpet, there are already plugins that Basically, they will scan all your logs and data, and based on that, they can predict what will happen on some days or some time, and just pop up instances just to be ready for those surges. And we got chaos engineering. Basically, you intentionally shut down and cause a failure to see how your system is holding up. Basically, a glorified QA. And it might sound wild, but this practice is great to understand your system limits and to build stronger and more resilient solution. Plus, and enhance observability with tools like distributed tracing, like OpenTelemetry and AI-powered log analytics, gives you a much deeper look into your system performance and the user behavior. And well, finally, we got emerging trends like edge computing and hybrid multi-cloud strategies and computational computing. So those are innovations that are bringing security and performance to new standards. And as I already mentioned, all these things exist for a couple of years, and I think as time progresses, this will just become another standard in IT environment, and perhaps tomorrow you will already see some of these things as requirements for a, I don't know, for a DevOps position or something similar in IT. But yeah, basically all the time you're learning something, and the learning never stops. I think this is the last one. Yeah. Yeah. I want to thank you all for your attention and time. And I guess questions were asked during the presentation, perhaps. If they were, they will be answered.
So I checked the comment sections. We haven't had any questions up until now. Maybe if there are any now. I don't know. We can give it a couple minutes. Thank you, Dominic.
Okay.
How
Great.
how was the experience?
Well, interesting. I didn't have a presentation seminar from my college years, so I will say like 4 years, and it's a
So
little
you
bit different
enjoyed
now
the
being in a
moment.
classroom. Yeah.
Yeah. Let me just check once again for questions if there are any. Uh-huh. I'm sorry if you can hear my cat.
No.
Okay. There seem to be no questions.
Okay. Great.
So I'm guessing that we can stop here and see each other next time.
Okay. Perfect. We'll see what we will do next time.
Awesome.
Thank you all.
Awesome. Thank you everybody for joining and hope to see you again next time.
Bye bye.
Bye.